Sleep ship archive. Transmission initiated. Vessel status stable. All primary systems nominal. Cryosleep monitoring nominal. Archive integrity confirmed. Voyage year 214. Tonight's archive record is drawn from the marine ecology files of old Earth. The subject, coral reef systems. The shallow water structures that once edged the warm oceans of the tropics, built across centuries by living colonies too patient to be witnessed in a single lifetime. This record is preserved for the colonists aboard this vessel, for those who will one day stand on new ground beside new water, and need to understand what a reef was, not as a fact to recite, but as something already known, something carried. You may rest now. The archive will do the work of the night. Coral reefs were found in warm, shallow, clear water. They required light, the particular quality of tropical sunlight pressing down through the first 30 meters of ocean. They required warmth. They required stillness, or something close to it. A slow, reliable current that brought nutrients without disruption. Where those conditions existed, reefs grew. They grew slowly, not in the way that a plant grows slowly, visibly inching upward across a season. More slowly than that. A single reef-building coral colony might add 1 to 3 centimeters in a year. A large structure, the kind that shaped the behavior of an entire coastline, might have taken 300 years to reach that scale. Some of the oldest living reef systems on Earth were 10,000 years old. Their origins predated written language. 300 years for a structure to take its shape. 10,000 years for a system to reach its fullest expression. These are spans of time the mind cannot hold as experience, only as information. But the body carries a different kind of understanding. The understanding that some things happen slowly not because they are struggling, but because slowly is the only way they can happen at all. The reef was not slow the way an obstacle is slow. It was slow the way deep time is slow. Patient without knowing, it was patient. This is one of the things the archive wants you to carry. The understanding of structures that grow without awareness of their own accumulation. That become what they are not through intention, but through repetition. Through the patient continuation of a small act, across a span of time too long to hold in mind. Coral reefs covered a small fraction of the ocean's total surface, less than 1%. And yet within that fraction, life concentrated to a degree found almost nowhere else on Earth, roughly a quarter of all known marine species. The open ocean surrounding the reefs held comparatively little. The reef held nearly everything. The reef did not simply occupy space. It created conditions that made other life possible. It was shelter, substrate, food source, and nursery simultaneously. Everything in the shallow tropical ocean related to it. Everything returned to it. The archive preserves this record not as a memory of something distant, but as a template, as evidence of what patient accumulation can produce, of what patience, given time, assembles without effort or intention. You carry this not as information. You carry it as something you already know and are being reminded of. The way certain things feel familiar before they are understood. To understand the reef, it helps to begin with the smallest thing, the coral polyp. A polyp is a small animal, very small. In most reef-building species, a single polyp is no wider than a few millimeters. It belongs to the same phylum as jellyfish and sea anemones. Like those animals, it has a simple body plan, a central opening surrounded by tentacles, soft tissue that draws in food and expels waste. This simplicity is not a limitation. It is a design so stable that it has persisted largely unchanged for hundreds of millions of years. The polyp does not need to be more complex than this. Its complexity is delegated to its partners, to its colony, to the reef that accumulates around it. The polyp does not move, it settles on a hard surface. Another coral skeleton, a piece of rock, the shell of a dead organism, and it begins to secrete calcium carbonate from its base, building a small cup around itself. A cup the size of a pinhead, a cup that is the beginning of the reef. The calcium carbonate that forms this cup comes from the seawater surrounding the polyp, dissolved minerals extracted and rearranged into solid structure. The polyp does not mine or gather. It simply draws what it needs from what flows past and adds it to what it is building. A single polyp building a single skeleton is an unremarkable event. It produces a structure smaller than a fingernail, and it lives, and in time it divides, not separating, but replicating, budding new identical individuals that remain connected through shared tissue, each building its own calcium carbonate chamber in the same way the first did. The colony grows outward and upward slowly at the pace of its own biology. The calcium carbonate accumulates, year by year, season by season, without urgency. The polyps build and divide and build again. The hard skeleton they leave behind persists long after individual polyps have died. Years, decades, centuries. What you are moving through when you move through a coral reef is mostly the accumulated skeleton of the past. The living surface is a thin layer over centuries of record. A reef that is meters tall, visible from above the water, sheltering thousands of species, began as a single polyp building a cup too small to see without magnification. The distance between that first cup and the full reef is not a story of ambition or effort or design. It is a story of continuation, of the same act repeated without variation until something vast emerged from its accumulation. You know this. The way something builds quietly, without announcing itself. The way it becomes substantial before it is ever noticed. The way foundations outlast those who laid them, and the outermost edge is the only part still adding to what came before. The reef carries most of its history inside itself, invisible. You carry yours the same way. The polyp could not survive on calcium carbonate and seawater alone. It needed energy, and energy in those warm, shallow waters came from light. But the polyp had no way to directly capture light. It had no chlorophyll. It could not photosynthesize. What it had was a partnership. Inside the tissues of most reef-building corals lived microscopic algae, single-celled organisms called zooxanthellae, that had been living inside coral tissue for so long that the relationship had become essentially inseparable. The algae photosynthesized, converting sunlight into sugars. They shared that energy with the coral. In exchange, the coral provided shelter, and the carbon dioxide and nutrients the algae needed to continue their work. This arrangement was the engine of the reef. On a good day, clear water, strong light, the right temperature, the algae could supply up to 90% of the coral's energy needs. The coral, in turn, was able to build its skeleton far more rapidly than it could have managed alone. The partnership did not simply sustain both parties. It produced something neither could have produced separately. The relationship had been forming for hundreds of millions of years. The algae did not choose to enter the coral's tissue exactly, nor did the coral choose to host them. The arrangement emerged and persisted because it worked, because both partners functioned better together than apart. The zooxanthellae found a protected, nutrient-rich environment. The coral found a source of energy that made all its other ambitions possible. The colors of the reef came largely from this partnership. The golds and greens and browns, the olive tones and pale yellows. These were the colors of algae seen through the transparent tissue of the coral. Where the algae were dense and active, the coral glowed with warm color. The reef's palette was a map of the partnership's health, showing which zones were thriving, where the light was reaching, where the conditions were right. When conditions were right, clear water, consistent light, stable temperature, the algae were present in enormous numbers inside each coral polyp. And the reef, seen from above or from within, had a particular quality. Warm, complex, softly luminous, alive in a way that felt quiet and continuous rather than dramatic. The reef was, in this sense, a living collector of light. An architecture evolved over millions of years to capture the energy falling through the first layer of the ocean and convert it, through this small, patient partnership, into structure, into color, into the elaborate community of species that would come to depend on it. You carry this principle, the understanding that the most productive arrangements are often not the most visible ones, that what sustains a system may be happening at a scale too small to observe directly, in a partnership too quiet to notice unless you know to look. The reef's engine was microscopic. What it built was visible from space. Light enters the ocean differently than it enters air. At the surface, it refracts, bending as it crosses from one medium to another, scattering slightly, beginning its transformation. A beam of sunlight that falls straight and clear through open air arrives at the water's surface and becomes something else, something softer, something that moves. The ocean absorbs light selectively. The red frequencies, the warmest end of the visible spectrum, are absorbed within the first few meters of seawater. Orange goes next, then yellow. The deeper you go, the more the spectrum narrows, until below 15 or 20 meters the world is illuminated almost entirely in blue and green. The light still present at 30 meters is not the same light that entered at the surface. It has been filtered. It has been changed. This is the light the reef lives in. In the shallows where the reef begins, the light is complex and variable. Sunlight striking a gentle surface produces shifting patterns, a web of bright lines that move across the seafloor as waves pass overhead, never repeating exactly, never still. The same coral surface looks different every few seconds depending on the movement of the water above. Deeper down, those patterns fade. The light becomes more even, more diffuse, arriving from all directions at once rather than from a single overhead point. The shadows soften. Colors that were vivid at the surface become muted. A red fish at 10 meters appears brown. At 30 meters, nearly black. The creatures of the reef have adapted to this. Their colors are not simply decoration. They are communication, calibrated to the depth at which each species lives and the light available there. A pattern that provides camouflage in the blue-filtered mid-range would be conspicuous in the shallows. Every color on the reef is a solution to the particular light problem of a particular depth. To look up from within the reef toward the surface is to see the water as a silver ceiling, shifting, refractive, bright by contrast to the world below. Light presses through it. The shadows of passing fish cross it. In clear water, the blue deepens as you descend, until the world above is a bright pale band, and the world below fades into cooler darkness. This gradient, from the complex, warm light of the shallows to the dim, filtered blue of depth, organized everything. The distribution of coral species, the behavior of fish, the location of cleaning stations, spawning aggregations, feeding grounds. Every living thing on the reef had found its position within the light, and its position within the light had shaped what it became. The colonists will stand on new ground beneath new suns. The light reaching them will carry different frequencies, arrive at different angles, behave according to the same physics but produce different effects. What grows will grow toward it. What lives will array itself according to what it offers. You already know how to read light. The knowledge is older than language. It is in the body, in the part that turns toward warmth, that knows the difference between direct and filtered, that reads the quality of an afternoon without being told what time it is. The reef understood light the same way, through long accommodation, through the slow shape that a life takes when it lives inside a particular quality of illumination long enough to become inseparable from it. A coral reef supported a density of life that was unusual by the standards of the open ocean. In the open sea, nutrients are sparse. Life exists but thinly, spread across enormous distances. The reef was an exception, a place where structure created shelter, and shelter enabled specialization, and specialization drew in more life than the surrounding ocean could sustain. Fish in numbers and varieties that staggered the count. Invertebrates occupying every surface and crevice, worms threading through the coral matrix, sponges filtering the water, algae colonizing any unclaimed surface, sharks moving unhurried along the outer edges. The species did not simply coexist, they were entangled. Their behaviors and needs had shaped one another over millions of years of shared proximity. Among the most remarkable of the reef's arrangements were the cleaning stations. At certain fixed locations on the reef, particular coral heads, particular ledges, small fish, mainly species of wrasse, established stations where larger fish could come to be cleaned. The larger fish would arrive and hover, sometimes changing color slightly to signal their readiness, and adopt postures of unusual stillness. The cleaner wrasse would move across their bodies, removing parasites, dead tissue, and debris from scales, fins, and even, with careful access, from inside the mouth and gills. The larger fish held still and did not eat the cleaners, though the cleaners were exactly the size of prey they would normally consume elsewhere on the reef. These arrangements were stable. The stations were known locations, visited repeatedly by the same individuals. Fish traveled distances to reach them. Species that were actively predatory towards small fish in other contexts became passive at the cleaning station, waiting their turn, allowing the wrasse to move freely through spaces that would elsewhere be dangerous. The cleaning station was one of the clearest examples of the reef's implicit agreements, the unspoken arrangements that governed behavior across hundreds of species simultaneously. The reef was not simply a physical structure, it was a sustained negotiation. A layered, ancient, continuously renewed understanding of how different kinds of life could share the same space and benefit from one another's presence. The clownfish and the anemone, the cleaner wrasse and the fish it tended, the parrotfish and the coral itself. The parrotfish is worth particular attention. Parrotfish grazed on coral. Their teeth, fused into beak-like structures, allowed them to scrape algae from the coral surface, and in doing so they sometimes took pieces of coral skeleton itself. The hard calcium carbonate passed through their digestive systems and was excreted as fine white sand. The white sand beaches of many tropical islands were in significant part the processed remains of coral. Passed through the bodies of these fish, deposited on the seafloor, carried to shore by currents over centuries. The reef made the beaches were the reef, transformed. You carry this, the way one system's byproduct becomes another system's foundation. The way the output of one living process becomes the raw material for the next. The way nothing is wasted when the system is old enough and whole enough to use everything. The agreement, the transformation, the exchange. These are patterns the colonists will need to recognize and eventually to build, not as rules to follow, as habits of observation to develop. The reef had a rhythm. It moved with the light. In the hours before dawn, the reef was in its nighttime configuration. The coral polyps had extended their tentacles into the darkness, small, translucent arms reaching into the water, catching the zooplankton and organic particles drifting past on the current. The polyp is a nocturnal hunter. In darkness it feeds. In daylight it retracts, drawing its tentacles back into the skeleton, relying instead on its algae. The same partnership that built the reef also governed its daily life. Day, the algae feed. Night, the polyp feeds. The reef ran two overlapping systems on alternating shifts, neither resting entirely, neither fully active all at once. As the sun rose and light pressed down through the water, the reef shifted. Night-active creatures retreated to their shelters. The moray eel curled back into its favored crack in the coral. The parrotfish returned to its mucus cocoon, a thin film it secretes around itself each night while it rests. Some fish gathered near the coral surface as the light increased, orienting themselves before dispersing into the day's activity. The day-active species emerged. Schools of surgeonfish swept along the coral face, grazing. Butterfly fish moved in pairs along the surface. The damselfish patrolled its small territory, the patch of algae it had cultivated and would defend against all comers. Light moved across the reef as it moves across any landscape. Long shadows in the early morning, picking out the structure of the coral faces in warm tones. The flat clarity of midday, flooding the shallower water with a brightness that washed some of the depth from the colors. The cooler shadows of late afternoon, lengthening as the sun moved, and the creatures that preferred those hours appearing along the deeper edges. By late afternoon, the reef was preparing. Fish schools tightened and moved toward the coral surface. Creatures that would spend the night resting began to locate their preferred shelter. The parrotfish found its sleeping site and began secreting its cocoon. And then the light would fail, and the reef would shift again, back into the configuration it had held every night across its entire history. The polyps extended. The nocturnal hunters emerged. The day's accumulation of activity settled into stillness. This rhythm continued across every day the reef existed. Billions of repetitions. The same pattern, varied slightly each time. Different weather, different currents, a different mix of species in each day's school, but the same fundamental structure. Light, activity, shadow, rest. There is no reef that does not move this way. The rhythm is not learned. It is the form the reef takes when light moves through it regularly enough and long enough for life to organize itself around that movement. The colonists on this vessel are in their own long rhythm, measured not in days but in years. The principle is the same. Repetition as foundation, pattern as stability. The shape of a thing is often just the shape of its rhythm, held long enough to become structure. When the last light drains from the water, the reef changes. The change is not sudden. It happens the way the reef does everything, gradually, without announcement, through the accumulated small adjustments of hundreds of species responding to the same signal. The signal is the absence of light. By full dark, the reef is occupied differently than it was at noon. The coral polyps have emerged from their skeletons. Their tentacles extend into the water, nearly transparent, nearly invisible, fine threads moving slowly in the current, waiting for contact. A polyp that feeds on zooplankton must catch it in the dark, by touch, by the faint chemical signals that drift through the water. The tentacle fires on contact, a microscopic mechanism, one of the fastest mechanical events in biology, and the prey is drawn inward. This is happening across the entire surface of the reef simultaneously, invisibly. The living skin of the reef is feeding. Other hunters are moving. The octopus, resting in a crevice through the daylight hours, moves out into the reef. It is among the most capable hunters in the shallow ocean, patient, capable of changing color and texture to match any surface, able to flatten its body through spaces far smaller than its apparent size. At night, with the reef's visual world reduced to what each creature can make visible for itself, the octopus moves slowly across the coral surface, feeling for prey, testing crevices with an arm. Some fish that school in daylight disperse into individual hunters after dark, moving through the reef in ways that the presence of the school would not allow. In certain species of fish and invertebrate, bioluminescence becomes visible in the water column above the reef, small, cold flashes of blue-green light drifting slowly. Not the concentrated brightness of the surface world, but something quieter. Life making its own light in the absence of the suns. Through all of it, the coral skeleton holds. The structure that the polyps built across centuries is unchanged by the darkness. It is there in the dark, the same way it is there in the light. Patient, providing surface and shelter and structure whether or not it is seen. The reef does not require light to persist. It requires light to grow. In darkness, it simply continues, doing the slower work that darkness allows. The listener is in their own darkness now. The vessel moves through a dark that makes the reef's night seem bright by comparison. No bioluminescence, no snapping shrimp, no current-carrying zooplankton past waiting tentacles. But the same principle applies. In darkness, the system continues. The slow work goes on. What was built during the light persists through what comes after. The archive continues its watch. The vessel holds its course, rest. The darkness is not an interruption, it is part of the rhythm. The reef had a sound. This is something the archive cannot fully preserve, and it acknowledges this. It was not silent. In the common imagination, the underwater world is a place of muffled quiet, a place where sound from above is filtered and distant, where movement is slow and the dominant sensation is pressure rather than noise. The reef was alive with crackling and clicking, with low rasping, with the constant soft static of the snapping shrimp. The snapping shrimp are small, most species no longer than a few centimeters, but they produce sound out of all proportion to their size. The snap is not made by the claw striking a surface. It is made by a jet of water moving so fast that the pressure drops low enough to form a cavitation bubble, which collapses with a small, sharp report. Each individual snap is brief, but the shrimp are always snapping, hunting, communicating, defending territory. And in a healthy reef, there are enough of them that their collective sound becomes a continuous ambient texture. You could hear them before you saw anything, before you understood where you were. The crackling arrived first, soft, persistent, like the sound of a signal between transmissions, and told you that something was alive in the water ahead. The parrotfish added their own layer, the quiet grinding of beak teeth on coral, audible underwater in a way that was almost surprising given how gentle the motion appeared. Damselfish chirped. Some species of grouper produced low grunts that moved through the water without urgency. At dawn, the sound shifted as the reef shifted, different species becoming active, different contributions entering the mix. At dusk, it shifted again. Night had its own acoustic profile. Lower, slower, different rhythms, The absence of the daytime schools replaced by the quieter movements of individual creatures, and larval fish and young invertebrates drifting in open water not yet settled on any surface, used this acoustic signature to find their way. They followed the sound through open ocean until they arrived. It announced its own presence. It sent itself outward through the water. A living system has a sound. The sound carries information about what the system is doing. This is something you will carry forward, not as knowledge to recall, but as a capacity the body already understands. You will hear the difference between a system that is whole and one that has gone quiet, between a room in the vessel that is functioning correctly and one that is not, between a community that is thriving and one that is under stress. The ear learns the sound of the normal before the mind articulates what normal means. The archive records what can be recorded. What remains is carried in you, in the part of attention that hears before it thinks. That part is already listening. It has been listening since before this transmission began. Once a year, or sometimes more, many coral species on a reef would spawn simultaneously. The event happened after dark, usually in the days following a full moon. There was no signal that was visible from outside the water, no audible change in the reef sound. And then, at a particular moment, different species of coral responding to the same environmental cues. The water above the reef began to fill. Small bundles, each containing eggs and sperm packaged together, released from the surface of the coral and began to rise. In reefs where many species spawn together, the bundles numbered in the millions, pink and white, pale and small, rising slowly through the dark water, visible even without light. Seen from underwater with a light, it looked like snow falling in reverse, patient, upward. The timing mattered because coral reproduction requires open water fertilization. Eggs and sperm from different colonies must meet at the surface and combine. The chances of this happening increase dramatically when many corals release at the same moment in the same place. The full moon was one of the cues the corals used. The tidal patterns associated with the lunar cycle provided a consistent environmental signal that synchronized spawning across a wide area year after year. The coral did not understand this. It simply responded to the conditions it detected: light levels, water temperature, lunar phase, in the way its biology had been shaped to respond over millions of years. The synchronization was not coordination. It was convergent response. Thousands of separate organisms making the same decision at the same moment for the same reasons without communication. For a few hours after the event, the surface of the ocean above the reef gathered these floating bundles into long, slow slicks, drifting with the current. Some would be fertilized, some would be eaten by the animals that gathered in large numbers during spawning events. Some would drift for days before a fertilized egg developed into a larva, and the larva settled on a hard surface somewhere distant and began to build a calcium carbonate cup. The reef was, in these moments, sending itself forward, trusting the current to carry what it had made to places it had never reached, releasing what it had built into the open water and accepting that it could not follow. The vessel moves through the dark. What it carries will settle somewhere and begin. The coral skeleton recorded the ocean. As a coral colony grew, it laid down calcium carbonate in layers, and the chemistry of each layer reflected the conditions of the water at the time it was deposited. The temperature, the acidity, the concentration of certain trace elements, the amount of light available. Cut a cross-section through a coral head and you find something like the rings of a tree, alternating bands of dense and less dense skeleton, each band corresponding to a season of growth. The dense bands form when growth is slower, during cooler months or periods of lower light. The less dense bands form during periods of faster growth. The alternation is regular, predictable, and readable. A researcher with the right instruments could look at a single band and identify the year it represents, could determine whether that year's water was warmer or cooler than average, could detect the presence of particular events, a storm that stirred up sediment, a period of unusually clear water, a shift in the local current. A single large coral head was, in this way, an archive, not a deliberate one. The coral did not decide to record. It did not preserve the ocean on purpose. It simply grew according to its biology, and the conditions of its growth were written into the structure of its skeleton as it formed. Every year of its existence was present in its body, layered, compressed, waiting to be read by those who knew how to read it, whether the coral itself was still alive or not. The archive on this vessel preserves knowledge deliberately. The coral did something quieter. It preserved knowledge as a byproduct of continuing to exist. There is a distinction worth holding here. The deliberate archive, the one that decides what to keep and how to keep it, is always incomplete. It preserves what it recognizes as worth preserving at the moment of preservation. The incidental archive, the one that simply accumulates, preserves everything. The quality of the light, the temperature of the water, the chemistry of the sea in a year that no one thought to record. The most durable records are often not the ones that were intentionally created. They are the ones that accumulated because something continued. This is something to carry forward. Into the building of systems, into the design of communities, into any long-term project. Build things that continue. The record will form itself, the layers will accumulate. What you cannot foresee recording, you will find already recorded if what you built continued long enough to keep growing. Continuity accumulates. What endures, documents. The reef systems of Earth were concentrated in a band around the equator, where the water was warmest and the light most reliably reached the shallow ocean floor. The largest was the Great Barrier Reef, along the northeastern coast of Australia, large enough to be seen from orbit, not as a sharp boundary, but as a pale, shifting pattern in the green-blue water, suggesting the presence of something organizing the sea below. From above, the reef's extent was not immediately obvious. What was visible was a kind of suggestion, a change in color, a difference in texture, a pattern that implied structure without making its structure clear. The reef did not announce itself from a distance. Even at orbital scale, it was something you had to know how to look for. It had been building for approximately 20,000 years, since the sea levels of the last ice age began to rise. As the water deepened, the coral grew upward, always maintaining the same relationship to the surface, to the light. There were other systems across Earth's oceans. The Mesoamerican Barrier Reef, running along the Caribbean coast of Central America. The Coral Triangle in the Western Pacific, where the convergence of ocean currents had gathered more species of coral and fish than anywhere else on Earth. The reefs of the Red Sea, which had adapted to higher temperatures and salinity than most coral could survive, and had persisted there, at the edge of what was possible. Each had its own history, its own sound. The reef was not one thing. It was a form that arose independently in different places, each time producing something locally distinct. The form was stable. The expression varied. In the archive's deeper records on coral reefs, There are notes on communities found at depths between 30 and 150 meters, below the well-lit shallows in the dim blue zone where light arrives filtered and indirect. Mesophotic reefs. The word means middle light. Middle light is not darkness, but it is not the light of the shallows either. It is what remains after the ocean has absorbed everything else, the reds, the oranges, the yellows, and what is left arrives diffuse and directionless, more blue than anything, present but not generous. To exist in middle light is to exist in a slightly muted version of the surface world. The colors are there, but quieter. The visibility is there, but softer. The life is there, coral, fish, invertebrate, adapted to what the light can offer rather than what it gives in full. These communities were less studied, and the archive acknowledges this. They are preserved here not as a complete account, but as a reminder that the known edge of any system is rarely the actual edge. The corals here spread wide and flat, plate forms, fan forms, maximizing surface area to gather what little light filtered down. The zooxanthellae within them adjusted their light-harvesting molecules to absorb more efficiently from the available spectrum. The architecture of the reef changed with the conditions, as it always did, finding the form that the available light could support. Different fish, different invertebrates. Some species found here were entirely different from anything in the shallows, adapted specifically to middle light, to lower current, to the different food web that develops when primary productivity drifts down from above rather than grows in place. Others were the same species found in the shallows, persisting at conditions well beyond their normal range, as if they had retreated to the quiet, dim layer below when the surface became difficult. When conditions in one zone become difficult, adjacent zones often harbor what can persist. The deep reef holds what the shallow reef loses. The shallow reef seeds the deep. Complex systems carry more redundancy than they appear to. The outer layers are not always the ones that hold a system together. Sometimes the quieter layer below is what allows it to continue. It is worth asking where the slow, dim, patient layer is, in any system, including the ones you will build. Where is the place in the system that continues when the surface is disturbed? Where is the reserve? Where is the part that operates at a different pace in a different light and holds what the surface cannot? A reef in the archive is not a single moment in time. It is a process. The reef as it appeared in any given decade was the accumulated result of growth and damage and regrowth across centuries. Storms broke coral, currents shifted sediment, sea urchin populations, which kept algae grazed back and reef surfaces clear for new coral settlement, occasionally crashed, allowing algae to overgrow the substrate. And then, in time, the urchins returned. The algae receded. Coral larvae settled again on the cleared surface. These cycles were part of the reef's normal operation. Some resolved over months, some over decades. The reef was always in process. The cycle of disturbance and recovery is not a sign that the reef has failed. It is the mechanism by which the reef remains alive. A reef that never experienced disturbance would not be a healthy reef. It would be a reef that had gone too long without the disruptions that open space for new settlement, that clear accumulated sediment, that reset the balance between competitors. Disturbance was part of the architecture. It was built into the system as surely as the coral itself. The colonists will build. What they build will be disturbed. It will be altered by events they did not foresee and could not prevent. A storm. A failure in a system that was thought to be stable. A change in the population of a species that was not expected to matter. Something will go wrong that was not in the plan. It will recover if given time. It will become something different from what they planned. And that difference will not always be a failure. Sometimes it will be an adaptation. Sometimes the recovered form will be more stable than the original, having incorporated the disturbance into its structure in ways the original design could not have anticipated. The process is longer than the disturbance. Structure returns. The reef demonstrates this without argument across centuries of record. Not that disturbance doesn't matter, not that damage is inconsequential, but that the timescale of recovery is different from the timescale of damage, and that understanding this difference is part of knowing how to build for the long term, how to build something that can absorb what it cannot prevent and continue. There were reefs before the ones the archive has been describing, long before the Great Barrier Reef, long before the coral polyp as it existed in Earth's modern era. In the ancient shallow seas of the Silurian period, approximately 430 million years ago, reef structures were built by other organisms. Stromatoporoids, tabulate corals, distant relations functioning in the same role but different in almost every detail. Substantial systems, forming mounds and banks across the seafloor of that era, large enough in some cases to have shaped the currents and sediment patterns of their ancient seas. These organisms are entirely extinct. Nothing that lives today is their direct descendant. They are known only from the rock record, from the limestone that formed when their calcium carbonate skeletons were buried and compressed across geological time. The record is incomplete. It shows the structures they made without showing the full complexity of what lived among them, and yet the function they served is recognizable. Warm, shallow, well-lit water, hard substrate, living organisms that extracted calcium carbonate from seawater and built structures that provided shelter and surface for others. The same basic arrangement, serving the same basic function, 430 million years before the reef that could be seen from orbit. They were followed by periods of global change that disrupted reef-building life extensively. The great extinction events of Earth's history, events that erased large fractions of all marine species, reduced reef systems to remnants or eliminated them entirely from the fossil record for spans of millions of years. Long recoveries followed, during which the form slowly reconstituted itself, built by new combinations of organisms, shaped by new conditions. But the form returned, each time. The warm, shallow, well-lit ocean floor has been organized by reef-building life for over 500 million years. The organisms that did the organizing have changed many times. The organizing principle has not. And at the center of it, unchanged across all that time, still the same small act. A tiny animal settling on a hard surface, extracting calcium carbonate from the water that surrounds it, building a small cup. Beginning. The form persists because the function persists. The colonists will arrive somewhere. The function will be the same, to find what the new place offers, and build the arrangement that allows life to concentrate around it. Not to recreate what was, to find the new version of the form. The form is stable. The expression will vary. The archive record for coral reef systems is now complete for this transmission. What remains is something quieter than summary. The polyp built without knowing it was building. The reef accumulated without awareness of its own scale. The skeleton recorded without intending to record. And somewhere in warm, shallow water, in the particular quality of light pressing down through the first 30 meters of ocean, a community of extraordinary density and patience made itself from these small, unremarkable acts, and held itself together long enough to be seen from space. You carry this. Rest now. Sleep ship archive. Transmission complete. Vessel status stable. Cryosleep monitoring nominal. All systems nominal. Archive records sealed and filed. Voyage continues. Please continue restorative sleep.